Okay, let me get our lecture started here. All right, so we'll start off talking about data structures in R. Okay, this is an important piece for our understanding and handling of R, and so I think you guys are familiar with a lot of these things, but we're going to kind of get down into the nitty-gritty and try to understand, some of the differences between these different things. Okay, so we've got homogeneous data types. And these are atomic vectors and matrices and arrays. Okay, homogeneous means all the values in this data structure are of the same data type. So everything is a character, or everything is a integer, or everything's a logical value. Okay, and you can create matrices of logical values or matrices of characters, arrays of these things as well. If they're all in one dimension, then it's an atomic vector. If you've got a rectangle of these things, it's a matrix. And if you've got more dimensions than two, it'll be an array. We can have different types. So if you want to mix characters and integers or things like that, you can create lists. And if you want to arrange them in a rectangle, then you have a data frame, okay? Or each column is going to be of a different type. So we've got 6 types of values in R: logical, double, integer, character, complex, and raw. And really, we just have to worry about the first 4, okay? I mean, you might deal with complex, you might deal with raw at some point, but probably not too much while you guys are here, okay? So we'll talk about all of these things. The logical vector, these are your true and false values, okay? And you can use uppercase T and uppercase F as shortcuts for true and false, but I recommend getting in the habit of using all caps true or all caps false, because those are reserved and they will always take on the values of true and false. You cannot change the value of true, you cannot change the value of false, whereas capital T, you can assign values to it. So you might say, like, let's keep a track of time using T, and you can say time at 2, time at 3. You may even have time equal to 0 for time at 0. But if you have time T equal to 0, then it will kind of behave as false, right? Because the value of 0 will get treated as false. So anyway, here we've got true is logical. You got a vector of these values, true, false, 3 false values. Logical. If you put something in quotes, then it's a string, right? And you can use double quotes or single quotes to establish things as strings. It doesn't matter as long as you match up the types, okay? Double quote, open double quote goes with closing double quote and single quote. I guess a thing to note is that in R we have to use the straight quotes, not the smart quotes. So like if you're on a word processor like Word and you use double quote, open quote, it's going to like angle them this way, and then when you close it, it angles them this way. You guys know what I'm talking about? R doesn't like those types of quotes. Okay, you got to use the straight quote marks. The default numeric type is type double. Okay, these are if you've got a decimal, it's definitely type double, okay? And then if you just type in the number 4, it treats it as double. R's default numeric type is a floating point number, type double, 4. You create this vector, combine 1, 2, and 3. It's going to be type double there. On the other hand, if you use the colon operator, you get integers, right? So integers don't have decimals. So the integer 1, the integer 2, the integer 3. If you want to just type in a value and have it treated as an integer, follow it by a capital L. Okay, so you can have 1L, and that will be integer type. The function C will combine different elements together, okay? So you can combine elements 1, 2, and 3 together, and you get this vector 1, 2, 3. You combine the characters hello, the string hello, and the string world, and you get a character vector hello world, okay? And if you try to, if you combine one vector, here I got vector 2, 3, and another vector with just the single element 1, it flattens everything, and you get one vector, one atomic vector. There's no like nesting hierarchy here, okay? It just flattens it out with combining. We can, a lot of times you can ask, what is the type of something by typing in type of, and it will tell you, as a character thing. So, you can say, type of, we'll say type of 2.5, okay? And what is this going to say? It's going to say double, right? And so this response, this is a character string that says double, okay? On the other hand, if you want a logical thing, you can say, is 2.5, is it double, okay? And this will be the logical value true, okay? So if you need logical things, such as, is something, that's not what I want, is it true or false? Okay, then you'll use the is function there, okay? So you got is logical, is character, is double, is integer, and then you also have is numeric, because we have two numeric types, right? We've got double and integer, and is numeric will return true if it's either numeric, if it's either the double or the integer type. Okay, quick quiz. All right, is.integer 3, true or false? False, all right? Is.integer 3:6. True. Is.numeric 3:6. True. Is double 3:6. False. Okay, very good. Is atomic will return true if it's an atomic vector, okay? Or I should just say if it's atomic. Let me fix that. So that will return true. Let me find atomic. Okay, so that will return true for atomic vectors and matrices. So, so a matrix will return true because a matrix is atomic. Is vector will return true if it's a one-dimensional data structure. So it returns true if it's an atomic vector. It also returns true if it's a list, which is a generic one-dimensional vector. Okay, so it will return false for a matrix because a matrix has two dimensions. It's not a vector. It's a two-dimensional structure. So is vector will return true for one-dimensional structures. Is atomic will return true for atomic structures, atomic vectors, or matrices. R is dynamically typed, meaning it will convert types or coerce types on the fly without complaining most of the time. So this is not true for other languages. So I don't know if any of you took Pick 10, where you had to program in C or something like that, but that's a strictly typed language, meaning if you declare something to be an integer, okay, and then later on you try to throw something that has a decimal value into that integer thing, it's going to either error out or drop the decimal portion of the value, okay? Whereas with R, it's just going to say, well, you started off with integers, but now you want decimals. Okay, we'll convert to decimals. Okay, we'll coerce our values into type double. Okay, and so here I'm combining the double value 1, okay, with a string, character string hello, and it says, well, because you're combining them in an atomic vector and everything has to be of the same type, we're going to coerce this to a character type 1, okay? Here I've got false and an integer, and so this will get coerced. The false gets coerced to an integer, which will be 0. Here I've got floating point double 1.2, integer 1, and the integer 1 gets coerced to a type double, 1.0. Okay, and so the way the coercion works is it looks at the when you combine something, it'll look at the least restrictive form and coerce all objects to that form. So here I've got a vector logical, true, false, true, integer 1, L, double 5, 6, 7, and character ABC. So if I combine the logical, integer, and double, the double is the least restrictive type, so it coerces the logical values, true, false, true, into type doubles, 1, 0, 1. On the other hand, if I combine the logical, the double, and the character, okay, the character is the least restrictive type, and so it's going to coerce the true, false, true into character vectors, true, quote, false, quote, true. Okay, so these are character types. Is that okay? So that will coerce them that way. When you have functions, these functions will a lot of times just coerce things for us automatically, kind of in the background without us worrying too much, okay? So here I've got false, false, true, and if we treated these as numeric, okay, so as type double, we're going to get 0, 0, and 1, right? So I've got false, false, true. I can just take x, okay, which is still false, false, true, and I can say sum it, okay? The sum function will coerce the false, false, and true into these numbers, 0, 0, 1, and then add them up, and we'll get 1, okay? If I take x, which is false, false, true, and I throw it into the function mean, it coerces the false, false, trues into zeros and ones, and then it says, what's the mean of 0, 0, and 1? And it's going to say the mean of that is 0.333. So it's effectively giving us the proportion of true, which is especially useful for us when you want to calculate proportions of, say a column. So you might have a character column or something, right? Maybe you ask, what's your gender, okay? And some people said, I'm identify female, and you want to say, okay, well, what proportion are female? So you say you create a logical comparison by saying, is gender equal to female, right? So you say gender equal female, and that will produce a logical vector of trues and falses. And then you can just directly throw that into a mean function, and so you can say mean of gender equal to female, and it will give you the proportion of females in that column. Okay, and so that's very convenient. Okay, being able to just call the mean function directly onto a logical vector, and R will coerce it and give us a numeric value. Okay. We can explicitly coerce things, okay? So you have as logical, okay? And this basically coerces everything to be true unless it's 0, okay? So as logical, so if I do as.logical, 1 will be true, as.logical 1.39 is true, as.logical -1 is also true, okay? The only thing that's not true will be 0, and I guess -0, okay? Those will get turned into to false, right? Oh, and as logical, the word false quotes, but I'm pretty sure this. Okay, so that gets. But anything else? Let's see. I don't really do this very often, so okay. So I guess if you try to do character things that aren't true or false, it'll give you NAs. But if you do give it number types, it's going to give you true and stuff. Okay. As.character, we'll just take whatever you put in there and put quotes around it. Okay, so as.character true gets true. Okay. As.integer just truncates things. Okay, it doesn't round. So as.integer 1.99 will get thrown into 1. Okay, it'll just look at the kind of the integer component. It's not a rounding function. It's turns it into integers. All right, as numeric, false gets turned into 0. If it can convert something, a string, into something that looks like a number, it'll do it if it can. And if it can't, it's going to give you an NA. It'll say, you know, warnings, NAs introduced by coercion. It might do that. So if you do like as double 7.3, it'll do that. What if I did as.integer? It'll get a 7. Okay. R is special, and we like it. Statisticians like R because it has this NA. Okay, this is kind of one of the special defining features of R, is that we have a value, NA, to indicate missing values. Right? Missing values is different. NA is not the same thing as null. Okay, it's different from NaN, which is NaN for not a number. Okay, NA specifically mean the value is missing or the value is unknown for us. Okay, it is something that exists, but we don't know the number. Okay, so for example, you might have a person, and you can ask that person, you know, what is your weight? Okay, and before that person responds, the weight for that person is unknown. That weight is NA. Okay, the weight exists. There is a value there, but it is unknown to us. And so, and if that person doesn't respond, then you write down NA to say that weight is missing. Okay, and as far as our data collection goes, it's an I don't know. Okay, it doesn't mean that the weight doesn't exist. That person has a weight. That person has a weight value. We just don't know what it is. Okay. You have, if you ask the type of NA, it is logical. Okay, and if you do an operation with NA, so you say NA plus 1, the response to that is also NA. Okay. So it's, for example, okay, what's this person's weight? I don't know. All right, what if this person's carrying a 1-pound brick? What's that person's weight then? The answer is I don't know, right? And so that's why you get an NA if you do an operation with an NA, because you're not suddenly going to know the answer when you try to do that, okay? However, if we say the NA plus 1, and we ask, and we get an NA, the type of this NA is type double. What happened there? It got coerced, right? So the number 1 is type double, and it got coerced. The NA, which was type logical, got coerced to type double, and it responds back with an NA of type double. Okay? So there's actually there's actually, you know, we have different kinds of NAs, okay? We have NA underscore character. We have character NAs, complex NAs, integer NAs, real, which is the type double NA, and you have NA, which is the type logical. Okay, so NA starts off as a logical type, and then it will get coerced into different types there. Okay, so we've got the NA real. NA equal NA returns NA. Okay, because that's like saying over here we have a person, we don't know this person's weight. Over here I've got another person, and I don't know this person's weight. Is this person's weight equal to this person's weight? And the answer to that is, I don't know. Okay, so NA equal to NA is going to give us an I don't know. It gives us an NA answer. If you want to know, is this something an unknown value, you have to say, is it NA? Is NA? And that's going to respond true. Okay. Over here, we have 4, 5, NA, and 3. Okay. NA means that the value exists, it's just not known to us, and so you have 4, 5, NA, and 3. Okay, so you can insert NA values into a vector like this. Okay. There's other special values. We've got not a number, nan. We have infinity and negative infinity. These are all type doubles, okay? Nan, even though it says not a number, is a type double. And don't use the computer to try to prove mathematical concepts here, okay? So you can do pi divided by 0, and you'll get infinity. You technically can't divide by 0, but you can kind of think of it as, it's not this, but if you do pi divided by 0, from the positive side, the limit is infinity, right? There is a negative 0, okay? All right, so pi divided by negative 0 will give us negative infinity and things like that. Negative pi over negative 0 gives us positive infinity. Anyway, okay. 0 over 0 gives us nan, meaning it's not a number. Okay. And if you try to combine nans with NAs, you'll get nans. For the interest of time, I'm going to skip this this quiz here. Okay. R will handle element operations element-wise. Okay. So here I've got the integer vector 1 through 4, 1, 2, 3, and 4, and the integer vector 2, 5, 2, 3, 4, 5. And if I add these two together, it will match up the elements element-wise. So the 1 goes with the 2 and gives us 3. This 2, the second element, goes with the second element, so the 2 goes with the 3 and gives us 5, so on and so forth. Same thing with multiplication, and if I did division or things like that, they would match up element-wise. And when we do this, the 4 gets matched up with the 5 and gives us 20 when we do multiplication. If you have a shorter vector, okay, so here I've got 1, 4, which is a length 4 integer vector 1, 2, 3, 4, and I've got 2, 3, which is a length 2 vector. It will recycle the elements. So it says, well, this thing has 4 elements and this thing has 2 elements, so I'm going to go 2, 3 and recycle 2, 3. And so the 1 goes with the 2 and gives us 2. 2 times 3 gives us 6. 3 goes with the recycled 2 and gives us 6. And 4 goes with 3 and gives us 12. Okay, so that's what happens there. On the other hand, here I've got 1, 2, 3, 4 multiplied by 2, 4. And so it sees the 2, 4 as 2, 3, 4, and says, well, there's only 3 elements there, so I'm going to recycle back around and start with the 2. And says, okay, now I have 2 vectors that are length 4, and I can do the thing. But it says, hey, wait a second, the shorter vector is not, the longer vector is not an even multiple of the shorter vector. And so I recycled back to the 2, but I didn't use the 3 and the 4, and it gives us a warning. It'll do the operation, okay, but it also complains and says, you know what, I just want to warn you that this is what happened. I'm not sure if this is exactly what you thought you were doing, okay? So it's just giving you a warning, but it says I've done it. And so here we get 1 goes with 2, 2 goes with 3, 3 goes with 4, and then the 4 goes with the recycled 2 and gives us 8, but we get a warning also. Okay. I want to talk about null, okay? Null represents the null object. Null is for things that do not exist. This is different from NA. NA is something that exists, but we don't know the value. It's a missing value. Null is for something that does not exist, okay? So if you say, what is the null type? It's specifically the null type, okay? And if you say, is it null? Is null the thing null? Is it null? Then that's going to respond with true, okay? Is null a missing value? That returns logical 0, okay? It gives us a logical vector of 0 length, okay? So logical 0 is a logical vector of 0 length. And you can create logical 0, you can create character 0 and things like that. So I just kind of want to show how this happens, okay? So if I put in, if I say A is 0 and B is 10 and D is pi, okay? We can call these things, and these are values that exist in my global environment, right? And I can ask, what are the things that are in my global environment by calling ls? And it says I got ls is A, B, and D, okay? If I delete everything in my global environment, I can do remove list equals ls, okay? Or another option to delete everything in your global environment is to hit the broom up here and you delete everything. And then if I ask ls, it gives me character 0, okay? Character 0 means the answer to your question, in this case, list off the names of objects in my global environment. The answer to that is a character vector, but there's nothing to list, so it's a 0 length character vector, okay? So, so that's what we have. Whereas null is just something, it's the null object. It's the kind of the empty set, doesn't exist. And so here we can just say, you know, is the null object a missing value? Okay, the is NA is supposed to give us a logical answer, true or false, okay? But it says, well, there was nothing for me to evaluate. You gave me a null object, okay? And so it's going to say, well, the answer to this thing is supposed to be a true or false, but there was nothing for me to evaluate. There was the null was there, so it gives me a logical vector of length 0. Okay, is logical? That's going to give back false, okay? Because logical, we'll say things like that. If you try to do operations with it, it gives you back 0 length vectors. And then over here, if I try to insert null into my vector, what happens? It's just something that doesn't exist. And so it just says 4, 5, and 3. Okay, 4, 5, comma, null, comma, 3 is just 4, 5, 3. It's just something that doesn't exist. You're inserting nothing into the vector. You're not inserting something that exists that's unknown, which is what an NA is. You're inserting nothing. Okay, it's the object that represents nothing, the null object there. Oops, sorry, I have to kind of clean up my slides a tiny bit. Here we've got lists now. Okay, so now we'll start talking lists. And so lists are generic vectors, meaning that they are one-dimensional in structure, but they can contain different types of R objects. So here, I'm creating a list of 4 elements. The first is a character vector with just the letter A. The second is a logical vector with true, false. The third is a numeric vector with the values 1 through 4 over 2. And the last is a function. Okay, you can throw that in there. And so here's my list of 4 elements. And we can ask, what's the structure of my list? It says you've got a list of 4 things, and this is what we have. Character, logical, numeric, which is type double, and a function. Lists, you can embed lists in other lists, and I think I want to kind of fix up this slide a little bit. List. Okay, so let me just render this quickly. Okay, so here I've got, it doesn't quite fit, does it? Okay, so here B is a list 5, 6, and 12, 13, 14. And C is a list with just one thing, 13. And if I create a list of B and C together, I get a list of 2 elements where the first element is a list of 2 and the second element is a list of 1. And so if I ask for the structure of A is a list of 2, where you've got basically B and C, and the first element, which was B, itself is a list of 2, which had 5, 6, and 12, 13, 14. Okay? And then the second thing, C, was a list with just the number 13. Okay? Notice the difference between the structures here. Okay? So here I've got X and I've got Y. These 2 things are basically the same. I've got list 1, 2 and C3, 4. And here I've got list 1, 2 and C3, 4. But here I'm combining them using a list, and over here I'm combining them with C. Okay? When I embed the list 1, 2 and the vector 3, 4 into the list, how many elements are in the list X? 2. It's a list of 2. Okay? X is a list of 2 where the first element is a list of 2 and the second element is a character vector. I'm sorry, is a numeric vector, but with values 3 and 4. So part of it gets cut off here. So let me just kind of, so here, I don't know if you can see that. So X is a list of 2 with the first thing itself being a list of 2 and the second thing being a numeric vector 3, 4. Okay. Whereas over here, I'm combining the list 1, 2 with the numeric vector 3, 4. And when I combine that, what happens here? How many elements are in list Y? Okay, it says there's 4 elements in list Y. So how did I end up getting 4 elements in list Y? What happened here? Yeah. yeah, it got coerced, and so it sees this thing and sees the list as the least restrictive type, okay, and it coerces everything to the least restrictive type, which is a list, okay. So the 3, 4 get coerced into a list, and we get a list of 4 there. Right? So these are just things to be mindful of when we are kind of combining lists, okay? So using list will preserve the hierarchical nature of the list, whereas combine does not, right? Combine is generally trying to produce a flat vector in general. With lists, you can name things, okay? Well, I mean, you can even name vectors as well. But so here I'm creating a list. Examp will be a list, and I've got A is equal to 1, B is a list with element C equal to 2 and D equal to 3, and then E is a vector 4, 5, 6. Okay? So the example list has 3 elements, A, B, and E. Okay? And B itself is a list of 2 with C and D. And so you can reference these things using the $sign. The $sign notation, you can say, what is element A in the example list? Examp $sign A, and it says, well, that's 1. Okay? What's examp $sign B? And it's a list where you've got C and D. Examp $sign C gives me null. Okay? Because at the top level, there's no C. C does not exist. Okay? So we get back null here. We don't get back a missing value. We get the thing that says this thing doesn't exist. Okay? If you wanted C, you have to say from example I want B, and within B I want C. Okay, so you can use $sign B, $sign C, and get back the 2. And then the 4, 5, 6 you can reference $sign E. Is that okay? How that list stuff works. With attributes, attributes are just additional what we call metadata that can be attached to any object, okay? And it can contain any kind of arbitrary information. The most common things will be the names and the dimensions in the class, but you can create any kind of attributes here. Okay, so here I'm creating a vector x. X is combined L equal to 1, M equal to 2, and N equal to 3. And so, here, quick question. What is the type of X? What kind of vector is X? X is a type double vector, right? Because the contents it's storing are the numbers 1, 2, and 3, which are type double. Okay? So it's a type double vector. But those values, 1, 2, and 3, have names, L, M, and N. And so if you ask, what are the attributes of X, it's going to give back a list that says, here are, where the thing that would contain are the names, L, M, and N. And you can say, what's the structure of the attributes? And it's a list of 1, where it just contains a character vector called names. Okay, and you can reference the things there, okay? Here I can change the names to A, B, and C. All right, and X is still a type double vector with the names A, B, and C now. And again, attributes can just contain any arbitrary data. And so here, I just create something called my attributes, and I just start writing in gibberish sentence that says this is not gibberish, but this is a vector, and that gets stored in there. Okay, so you can think of attributes as kind of like a tag or a piece of paper of information that just kind of gets stapled on to the vector, okay, or the object that you're dealing with. Okay, most attributes, when you modify it or subset it, they get lost except for the names, dimension, and class, and we have shortcuts to get these things. So you have the name, names, and dimension, and class. Okay, so dimensions exist on matrices. Okay, so if you have a a vector without any dimensions, then it's going to be an atomic vector. If you attach a dimension attribute, then you'll produce a matrix. Okay, so here are the attributes of X. When we subset X, it gets rid of all the other attributes other than the names. There are different ways to set names, okay? So don't worry about that. And an important thing is kind of the creation of factors, okay? So factors are used to store information about categorical variables. So that's what we've got here, okay? So if you got categorical information, that will be stored as a factor. And so a factor contains an attribute called levels, okay? And basically, what we do is, let's say we wanted to take a survey of students and we wanted to say, did you start here as a freshman, or were you a transfer student, or does something else describe your status here, okay? And so rather than having to write started as freshman, person 1 is transfer, person 2 started as freshman, person 3, we can just say, okay, this person is category 1, this person's category 2, this person's category 1, type of that, okay? But then we'll need to have some kind of thing that says category 1 means started as a freshman, category 2 means is a transfer student, okay? And so so that's what happens in a factor. And so in a factor, it's actually stored as an integer. It codes the things as 1s and 2s and 3s, these integer values, and then somewhere else you've got the levels. It's an attribute which says 1 corresponds to started as freshman and 2 corresponds to is a transfer student, or something like that. Okay. Factors only allow you to add values that exist within the levels. So if I tried to so here, we just have A, B's, and C's, okay, A, B, B, C, A. So these are the levels A, B, and C. And so if I tried to throw in the value D, it's going to say this is not a valid factor level, and it inserts an NA. Okay, but again, factors are integers. And so they get stored as 1, 2, and 3, and over here it kind of corresponds. The labels show up here under levels, okay? And then over here the class is stored as a factor, okay? And you can kind of just you can manipulate these things and whatnot, okay? You can't combine factors and stuff like that. A lot of times when you use something like read CSV, or you create a data frame, the default behavior is to turn strings into factors. And so just be mindful of that. Sometimes you want to leave things as strings. And so if you want to leave them as strings, set strings as factors equal to false, and that will preserve the string nature of the stuff there. Okay, all right, we'll talk a little bit more. I have posted a homework assignment on CCLE, okay, and that'll be due 1 week from today, next Wednesday at 6 p.m. Okay, and the instructions for that, you'll download the R Markdown template, fill in your answers, and render it as HTML and upload that back onto CCLE, okay? All right, we'll see you guys on Friday.